You see the news alerts pop up on your phone. Somewhere out in the vast Pacific, the Earth trembles. It's a massive earthquake, a magnitude 7 or 8, and the warnings go out, tsunami. You probably picture a colossal wave, like something from a disaster movie, cresting and crashing down on a city. And that's the general idea. This is a tectonic tsunami, one of the most powerful forces on our planet. It can cross the entire ocean at the speed of a jetliner and erase a community from the map. It is terrifying. It is deadly. And it's basically a ripple in a puddle compared to what we're going to talk about today. Because what's worrying geologists in Alaska right now isn't just another earthquake. It's the possibility of something so much bigger, so much faster, and so unbelievably tall that it makes a regular tsunami look, well, small. Today we're talking about the mega tsunami. To understand this, let's look beneath the waves, at a cross-section of the ocean floor. Imagine two immense plates of the Earth's crust are locked together, grinding against each other. For decades, even centuries, the pressure builds. Then suddenly it slips. One plate violently shoves upwards by several feet. Now, a few feet might not sound like much in a deep ocean, but this isn't a small event. An area the size of a state can be thrust upwards. And when that happens, it lifts the entire column of water above it, from the seafloor to the surface. This creates a wave, but not a typical one. In the deep ocean, you might not even notice it, as its height could be just a foot or two. Its true power is its immense wavelength. The distance from one crest to the next can be hundreds of miles long. As this incredible amount of energy approaches land, the ocean gets shallower. The wave has to slow down, and all that energy is forced upwards. The water builds not into a surfer's curl, but into a relentless, fast-rising surge that just keeps flooding inland. That's your classic tsunami, a massive volume of water being pushed. Remember that word, volume. Now let's forget all of that. A mega tsunami is a completely different animal. It isn't caused by the seafloor pushing from below. It's caused by something falling from above. Picture a place with steep, dramatic coastlines, like a deep fjord in Alaska or Norway. Now imagine a massive, unstable mountainside right next to that water. Or for a more cosmic example, picture a giant asteroid hurtling toward the ocean. A mega tsunami is born when a colossal amount of material, rock, ice, or even space debris, crashes into the water all at once. It isn't a push, it's a splash. Think of it this way. If you slowly lift the floor of a bathtub, the water level rises evenly. That's our tectonic tsunami. But what happens if you drop a bowling ball from a high ladder into that same tub? You get a violent, chaotic eruption of water that flies up the sides, far higher than the original water level. That is a mega tsunami. It's not about volume spread across an ocean. It's about creating the most extreme wave height imaginable in one location. And this isn't just a theory. It really happened, and the story is chilling. Let's go back to the evening of July the 9th, 1958. We're in Lituya Bay, a remote fjord on the Alaskan coast. 3 fishing boats are anchored for the night. On one boat is Howard Ulrich and his young son. Suddenly, the world begins to shake violently from a massive magnitude 7.8 earthquake. From his boat, Ulrich hears a deafening roar from the back of the bay. He looks up and sees something that shouldn't be possible. The entire side of a mountain had sheared off and was plunging into the water. We're talking about 90 million tons of rock and ice. It was, for all intents and purposes, a mountain falling into a bathtub. What happened next created the legend. The impact generated a wave so immense it defies description. This vertical wall of water was so powerful that it scraped the mountainside on the opposite side of the inlet clean, to a height of 1,720 feet. Let that number register. 1,720 feet. That's over 500 meters. For perspective, the Empire State Building is 1,454 feet tall at its tip. This wave was taller. The famous Eiffel Tower in Paris. The wave was more than 1.5 times its height. This was a liquid monster that power-washed the trees, soil and rock right off the landscape. Down on his boat, Howard Ulrich saw this wall of water racing towards him. He could only point the nose of his boat directly at it. He was lifted, as he described, like a surfboard, up the face of this impossible wave. He looked down and saw the tops of 80-foot-tall trees below his boat. His anchor chain snapped like a piece of string. He was carried completely over the spit of land at the bay's entrance and thrown out into the Gulf of Alaska. Incredibly, Howard and his son survived. Another boater, William Swanson, also rode the wave and lived. The third boat and its 2 occupants were never seen again. That wave, moving at over 100 miles per hour, left a permanent scar. You can still see photos of the trimline today, where the ancient forest abruptly stops and younger trees begin, marking the high water mark of a wave taller than a skyscraper. So that was 1958. A freak event, right? A 1 in a million occurrence. This is where the story comes back to today, and why Alaska tsunami is in the news. Let's pull up a satellite map and zoom in on another spot in Alaska, a fjord in Prince William Sound called Barry Arm. At the head of this fjord sits a large, unstable slope of rock and earth, weakened by a rapidly receding glacier. Sound familiar? Scientists are watching this slope with satellites and radar. They've seen it moving, and they've run the computer models based on what happened in Lituya Bay. Their worst-case scenario isn't science fiction. If that entire unstable slope fails at once, it could trigger a mega tsunami hundreds of feet high inside the fjord. This isn't an ocean-wide event with hours of warning time. This is a sudden splash that would hit nearby coastlines in minutes, threatening anyone in its path, from fishermen and tourists to the residents of nearby towns. Because the land is already moving, it's not a question of if it will fail, but when and how fast. So there you have it. Two kinds of monster waves. One is a problem of volume. The entire ocean floor shoves a massive amount of water across the globe. It's wide, powerful, and travels vast distances. The other is a problem of height. A sudden, violent impact that creates a localized but absurdly tall wave that defies the imagination. A geological splash of apocalyptic scale. The story of Lituya Bay serves as a chilling reminder. It's the benchmark for the raw power our planet can unleash, showing us that for as scary as a normal tsunami is, there are forces of nature that operate on a completely different level. And in places like Alaska, those forces are still active today.